One of the most interesting, challenging and exciting aspect of planning the operations of an airline is to schedule the flights and to manage the disruptions which are inevitable. This is a very complex subject, and today we will take a peek at its complexity. First, we talk just about airline scheduling. What is airline scheduling? In airline scheduling, we basically are interested in designing the system-wide flight patterns. Which aircraft will operate from which airport to which airport, and in that aircraft who will be the pilots, who will be the crew members. Now, this particular exercise cannot be done just in isolation or as per the whims and fancies. It has to ensure that while you provide optimum public service, you also maintain airlines' financial health. In other words, designing a schedule without consideration for the fact that airlines are basically a business, and any wasteful expenditure is going to create a lot of problems and hurt the bottom line. And if you don't do it properly, you are sure to be out of business very soon. So, it is a very important function and a very complex one, because it is very dynamic in nature. Also, the scheduling cannot be done also in isolation. There are many factors which affect scheduling. There are internal factors which are like the equipment maintenance route procedures and schedules. The crews utilization should be efficiently done. There are constraints at the facility because of gates, positions, ticket counters. There could be marketing effects like how much traffic is available, what is the load factor. There could be constraints from the fuel capacity of the aircraft. So, you might like to connect city A with city B because there is a tremendous demand, but the aircraft that you have in your kitty may not have the range to fly from A to B directly. So, you may be forced to go through B, through C, and that is also a constraint. Similarly, climate issues, whether in summer or in winter, you will have constraints on that. There are also some external constraints. For example, there are flight curfews imposed by the local communities to ensure that you do not fly at times when they are resting or sleeping, like the night times. At many airports, there is a curfew of flights from 11 p.m. to morning 6 o'clock. Then there are constraints because of local community and disturbances. The hotel and motel operators, they also sometimes lead to some factors which affect scheduling. For example, all hotels and motels, they have a certain check-in time and check-out time, and they would like the passengers to be able to operate in such a manner that they are able to meet without the requirement to stay for one more day or pay for one more additional day. They are able to take their flights. Travel agents impose some external constraints. They tell you what are the preferable times during which the flights can be expected to go full. The air freight shippers who provide you with cargo, and that adds to the bottom line of the airline quite considerably in many cases. They will decide the time by which they are able to supply the cargo to the airport at some cities. So, that may also affect the time. Coupled with all these internal and external factors is the competition, because the competition by other airlines can also force you, and with all these things you come up with your schedule. There are 4 principal tasks in airline scheduling. Let us have a look at them one by one. The first task is the schedule generation, which is a competitive timetable to meet the potential demand, and it should have some buffers to recover from the delays which are inevitable or expected. For example, early morning and late evening flights generally have larger buffer in them because there is a higher probability of congestion at these times. So, the flight from Mumbai to Delhi, it may be 1.5 hours during the daytime and 2 hours during the peak time, because there is a buffer built in. Otherwise, the aircraft will always be reported as late, and that affects the image of the airline. Fleet assignment: which aircraft type have to be assigned to a particular sector so that the revenue is maximized. Now, if an airline has got a single fleet, then there is no such problem, but most airlines, especially the large ones, they have a mix of fleet. They have small aircraft, medium aircraft, long aircraft, large aircraft, and they would like to ensure that larger aircraft are deployed on the hub routes and the smaller ones are on the spoke routes. So, this is the important requirement of fleet assignment. Then you have aircraft routing. Okay. Which particular aircraft has to fly from which city to which city and then from there to what city, that is called as routing. So, this is also an important task. And finally, aircraft are operated by crew members, both cabin crew and cockpit crew. The next aspect is crew rostering. Aircraft are operated by crew members, the cockpit crew and the cabin crew. Now, all of them operate under regulations. Not every cockpit crew member is available every time. Not every cabin crew member can be scheduled because of duty limitations. So, assigning flight duties to specific crew members to maximize resource efficiency and to result in equitable distribution of workload, that is also an important aspect of scheduling. So, these 4 tasks, when done together, comprise the whole gamut of airline scheduling. Let us have a look at resource utilization and synchronization. Resource utilization is a very key aspect of efficient operation of airlines, and that is the key goal of airline scheduling, because wasting the resources, aircraft or crew, are very expensive. It can lead to a very big hit to the bottom line of the aircraft. So, it is very important to ensure that the aircraft and the crew members are optimally utilized. Resource synchronization. This is also very important, pairing and matching of resources that can't operate independently. As I mentioned, not every aircraft can be flown by every crew member. Okay. There are certain pilots who are qualified or certified to operate or licensed to operate a particular aircraft. It is not enough to position a pilot, you have to position a pilot that can actually fly the aircraft. Similarly, maintenance crew members. So, it is very important to pair and match the resources. After generating the timetable, you have to perform synchronization again at 4 levels. Synchronization of aircraft fleets with flights, flights with specific aircraft and PAX itineraries, aircraft with cockpit crews, that is called as crew pairing, and rosters for each crew members and crew pairings to ensure equitable distribution and to ensure that they are operating within the regulatory constraints. Schedule generation, also called as timetabling, involves many factors. First of all, it is based on the forecasting of the demand on each sector. So, take a sector from I to J. So, we decide the departure time for each origin destination pair and frequency F as follows. Frequency will be equal to the demand from I to J divided by the passenger capacity of the aircraft into the load factor which is expected. Okay. Then higher frequency is more appealing for the passengers because they have to wait less for the next flight, and it helps in increasing the market share, but there is a word of caution. Offering too much frequency without the requisite demand can lead to wasteful utilization of the aircraft, it can lead to lower load factors, and that can become detrimental to the bottom line. So, there is an optimal frequency which has to be arrived at based on experience, based on very accurate modeling of the demand and prediction of how much will be required, how many flights will be required by each aircraft to meet the requirements. The schedules are generated twice a year because there is a lot of effect of the summer and the winter on the schedules. Generally, they are made twice a year. So, in winter, which is October to March, and summer, which is April to September, there could be differences in the schedules which are operated by an airline, but we have to announce them months in advance, as much as 8 to 10 months in advance. Okay. However, it may be noted that most of the bookings, especially on the long route by economy class passengers, they take place only about 3 months before the departure date. Okay. And closer to the time, you will have last minute passengers and business passengers. So, therefore, the passengers should be aware of the schedule which is being operated. So, you cannot do scheduling in the last minute, you have to do it much in advance and communicate to the various booking sites. Deciding size versus frequency. This is a choice that is being faced by a scheduler on a regular basis, and we will look at one example. Let us consider an airline called as a Faltu airline, which has predicted a daily demand of 1000 passengers from a city AAA to BBB and back, which means 2000 passengers go from AAA to BBB and 1000 passengers come back, not the same, but some other passengers from BBB to AAA. Now, this airline offers a single class cabin, mostly economy, with all economy seats. Okay. Now, we have an option. It has got 3 types of aircraft in its kitty. The first is Airbus A380, the second is A330, and the third is Boeing 787. The max capacity of A380 in this particular configuration of the airline is 550 for A380, nearly half of that 280 for 330 and 200 for Boeing 787. Now, if you offer one flight per day by Airbus A380, you will be able to provide a total capacity of 1100, which is 550 going, 550 coming. But if you operate 2 frequency of 2 flights a day with the capacity of 280, you are going to give 1120 available seats for going and coming. If you, on the other hand, operate an aircraft with 200 seat, that is Boeing 787, you will be able to offer 3 into 200 into 2, that is 1200 seats, okay, to go and come back. Now, when we operate one Airbus A380 per day, then a demand is 1000, but we have an excess capacity of 100. The usage of 330 with 2 frequency per day leads to an extra of 120, and Boeing 787 gives you 200 more passengers. Now, the question is, it is a difficult choice for the airline to decide which of these 3 options is the best option. Offering higher frequency generally makes the load factor increase. So, you might say that it is better to operate Airbus A330, which offers double 2 frequency. Although the excess capacity is more than that with Airbus A380, still because of the higher frequency, you can have better chance of getting more passengers. But somebody may argue that no, at the cost of 200 extra seats, it is better to operate Boeing 787, which is a smaller aircraft flying a frequency of 3, because definitely you can wean away the market from other airlines to your airline by offering this kind of a frequency. Somebody might say, no, let us be purely cost conscious because we are already bleeding a lot of money. Let us only offer one flight by Airbus A380, which will take care of the requirement with the minimum possible excess capacity, and by itself it is going to meet the market requirement. But is it true that all 1000 passengers want to travel at the same time? Because they might prefer to go by some other airline if it is available. However, if you are operating at an airport where you are the only airline flying, then all these 1000 people will have to travel only when you offer your flight. Now, one can use hub and spoke networks to ensure that the 1000 passengers are not going to one destination, but they are from this hub to multiple spokes at the other end, and they are being put together in one big aircraft. So, it all depends on the scenario in which you are operating. There is no correct answer to this question. So, the cost per seat is the lowest for the largest aircraft and the highest for the smallest aircraft, and it is medium for the middle aircraft, but that may not be the only consideration. Now, let us have a look at fleet assignment. Fleet assignment basically means you allocate the available aircraft capacity to meet the potential demand, and it also means that the potential demand is being met by allocating the appropriate size of the aircraft, the aim being to maximize the potential profits. Now, you can use different aircraft types at different routes, use larger aircraft on trunk routes, because that will give you, the problem is it will give you lower frequency, but does not matter. On thinner routes, use smaller aircraft because you can give higher frequency there. Now, this is an inherently challenging problem. The problem is that demand forecasts are very uncertain. You do not know in advance, but capacity of the aircraft is fixed and it cannot be changed arbitrarily at a very short notice. You cannot say that, oh, demand is less, so remove the last 7 seats in this flight and we will put them again in the next flight. It is not so easy. Okay. Sometimes it is possible, but it is not very easy to do it. Here is another example of a typical challenge in fleet assignment. An airline called Bakwas Airlines, it predicts a daily demand of 210 passengers from city CCC to DDD and back. Right? Now, demand is uncertain, so it will be 210 plus 25, that is 235, or 210 minus 25, which is 185. So, the demand will vary as per predictions between 180 to 235. If that is the case, let us look at the options. They have two aircraft types, A and B. The capacity of A is 240 and B is 180. So, if we are looking at 210 plus minus 25 passengers, then you are actually going to carry 55 extra passengers, right. Whereas, if you travel by B, you will carry 180 passengers, which will be 5 less than the least 185. Similarly, if you look at the number of seats, if the demand increases or high, you will notice that with one flight of this aircraft A, you will have 240 passengers, which is 5 more than the maximum that you expect. And if the demand on the other hand reduces, if you travel for example by aircraft B, which is 180 seats, and the demand is 245, you have 55 seats less than what you could carry. Now, the load factor percentage, the load factor by demand, let us say it is 77% for the first one, because you are basically carrying 240 seats are available and only you are carrying only about 185 seats. So, you are operating at 77% load factor. In the case of B, you are actually having seat deficit. You are not able to meet the demand. You will go full, your load factor will be 100%, because the seats available are, seats required are more than seats available. Now, the load factor demand, if the demand increases, turns out to be 98% in the first case and it is 100% in the next case. So, the load factors are almost similar. Now, the question is, the total operating cost per route is going to be higher for the larger aircraft, but the operating cost per passenger will be lower. The total operating cost per route will be lower for the smaller aircraft, but it will be higher per passenger. So, now the question is whether you operate A or B, which aircraft do you deploy in this particular market. Now, if you are conservative, you will say, look, let us go for B, because B will definitely meet the requirement of 185, the minimum requirement, and we will go with full load factor, but we have lost out on either 5 or 55 seats depending on the demand. If you travel by A, your load factor is almost 98%, but you are now carrying either 55 seats more than the minimum demand or 5 seats more than the maximum demand. Okay. So, it depends on your operating scenario and it depends on what factors are in play. You might choose A or you might choose B. The load factor leverage is very important because every empty seat in the aircraft is an opportunity wasted by the airline, and therefore, it is very important to ensure that you do not have many seats vacant. Now, it may not be a good idea to always look for 100% load factor, because if you go for 100% load factor, then the passengers get the impression that we will not get last minute seats in this particular airline. They always fly full, and passengers do not like the aircraft to be completely full. Okay? They would like to have a few seats empty, but every empty seat costs airlines some money. So, it is a trade off between image and operating cost versus the delta load factor. Now, small increase or decrease in the load factor can lead to a large effect to the profit and loss of the airline. Okay. Another important aspect of scheduling is the tail assignment, which is called as TA. What is tail assignment? It is the aircraft routing. Each aircraft has a unique aircraft registration code or ARC, which is painted on the vertical tail. So, each aircraft has a specific number. Now, by tail assignment we mean which routing is to be given to each individual aircraft, so that we meet the maintenance requirements, but we have some flexibility also, so that we can not have a situation where the flight has to be cancelled or delayed, because there is no flexibility. Now, there are many levels of aircraft maintenance. Now, I must also tell you that you will be able to experience this particular aspect through an tutorial which we have already created for you. In that tutorial, one example of 4 cities and 4 aircraft will be done, and we will show you how we can manually try to do the aircraft routing, but it will also be shown to you that it is a very complicated process, and therefore, most airlines nowadays use dedicated computer programs for carrying out the maintenance. The levels of the aircraft maintenance also affect a lot. There are certain routine maintenance checks which are performed between flights or overnight between the aircraft reach the destination at the end. But you also have major maintenance checks for which the aircraft has to be taken off from normal service and sent for the maintenance. Okay. So, now for a narrow body airliner, here is an example of some rough numbers for the various checks. The checks are called as line maintenance check or check A, check B, check C, check D. Now, there is no uniform number for this. This is decided by the manufacturer or the OEM of the aircraft, the original equipment manufacturer, and the airline and the regulatory bodies. They sit together and decide when these checks are going to be done. Broadly speaking, the line maintenance happens between every 2 flights. Check A within 8 to 10 weeks of flying, check B 6 to 8 months of flying, check 3 18 to 24 months of flying, and check D can happen once in 6 to 10 years of flight. How much time is needed by the maintenance engineers to do these checks? The line maintenance guys can do it within an hour's time, 30 to 60 minutes. A will require 6 to 24 hours. As you go down, you will realize. Now, if an aircraft is due for check D, it is out of service for approximately 5 to 6 weeks, and that is a lot of time. Okay. How much maintenance man hour is required to do this check? Probably 2 maintenance man hours are enough for the line maintenance, but you may require around 60 for the one that is check A, 180, 6,000 and more than 10,000 for the last one. So, the between each flights you do the line check. Check A is done after either 200 to 300 trips or between 400 to 600 hours. In many cases, check B is merged with check C, and in some airlines what they do is they say that they will do a part of check C every time they do check A or B, so that they do not have to keep the aircraft away for such a long time. Okay. And check D is the most extensive because the whole aircraft is dismantled, inspected, repaired and reassembled. There are some challenges in tail assignment. The maintenance schedules have to be strictly followed. You cannot take exceptions regularly, you can have once in a while. And therefore, it is important for you to position the aircraft just in time at the maintenance base. If you arrive too early, then aircraft is just idling on the ground, you are wasting the opportunity of earning money. If you are not able to do it properly, then you may be forced to make one flight without any passengers just for placing the aircraft for maintenance check. That will be called as a non-revenue flight for positioning. This can be very expensive and should be minimum. So, you have to also balance the aircraft wear and tear due to operation conditions. Some things go more bad in hot and cold conditions, some things go more bad because of the takeoff and landing cycles. So, you have to balance the wear and tear and look at the operating conditions. I will give you an example of a typical challenge in the tail assignment. I have taken an example of a theoretical airline, domestic airline operating in India. So, assume that all the flights are originating from D, which is at this location, and they have to end at Mumbai, which is M for night maintenance. So, this airline has got its night maintenance at Mumbai. So, there is a requirement that everything should start from Delhi and it should end at Mumbai. Okay. So, one routing that can be done is this, where you go from Delhi to Kolkata to Delhi to Hyderabad to Kolkata to Mumbai. That is called as routing number 1. In this routing, you have 1, 2, 3, 4, 5 flights. You have another routing number 2, where you go from Delhi to Ahmedabad, to Bangalore, to Goa, and then to Mumbai. Now, in the previous one, we were arriving at the airport at 8 o'clock, whereas you want to reach just before midnight. In the number 3, you are travelling only from Delhi to Chennai to Delhi and then to Mumbai. You are doing 3 flights only, but at the end of 3 flights, you are reaching there at 8 p.m. So, now you have to look at it. Okay. The maintenance timings are from 2300 hours to 700 hours, which means this aircraft is reaching, the one which is reaching at 1800 hours is unnecessarily spending so many hours on the ground. The one which is coming at 2200 is just in time, 1 hour before, with some 1 hour margin for delays. Now, it is up to you. One of the routes, route number 1 gives you maximum number of flights, but the plane arrives just 1 hour before. Someone might say this is the best routing, more travel, more flights and less maintenance time wasted, but somebody might say no, it may be better to, so it depends on the situation. Okay. Now, what is crew scheduling? Matching the crewing requirements of different fleets with the routings, so that you can have 2 important aspects here, crew pairing and crew rostering. What is crew pairing? Series of flights for the crew member. So, the crew member normally would like to start and end at the same location, so that you do not have to book a hotel accommodation for that person. He or she can start from their own house, do the operations for the day and come back to the same city and go home. This can happen over 1 day or many days. So, there may be intermediate stops at other destinations, and you have to ensure that you do not stay very much away from the base, because then you may have to compensate. You have to also meet legal requirements, because there is requirement that in 24 hours a pilot can only fly for about 8 hours. Okay. There are what is called as flight duty time limitations, FDTL. Then there are crew bargaining arrangements. So many flight hours per year is maximum, you can't have more than that. Then crew rostering basically means assigning crew to individual flights. Now, here you have to meet the requirements and constraints. What are those? First thing is a skill requirement. As I mentioned, you can only fly, a pilot can only fly one aircraft type at a given time generally. Then there are crew sizes. You need minimum crew members in an aircraft for 8 hours, and it may be required for you to send a crew member from A to B to take a flight from B to C, because there is nobody available at B. That means you are going to deadhead a crew from A to B. They will travel like passengers. Several times in flights you notice there are captains or pilots sitting with the uniform as passengers, they are required to be positioned to the next destination to support the operations. Typical bargaining agreements are there. There is something called a flight duty time limitation. It could be per day, it could be per week. There could be day off between duties. Then there are rest days mandatorily provided by the regulatory bodies for difficult. For example, when you travel in multiple time zones, you can get more disoriented, or if you cross the international date line multiple times, you will get more confused. So, there are mandatory rests available. There are annual leaves available for each crew member, and then based on the agreement, there are guaranteed working hours per roster period. An example of some constraints: this captain might say that I can only have a 8-hour duty time as a pilot of 2-person crew. This one can say I will get an 8-hour rest prior to exceeding beyond those. Some other crew member might say we require 8 hours to rest in 24-hour period including a flight, that includes a flight. Someone can say we can't exceed 40 hours of flight in 7 days including 24-hour break. Someone can say for every 4 hours away from home I get 1 hour pay. So, all these factors are very carefully monitored and managed when we assign the aircraft and the crew members. Now, finally, we look at disruption management. Disruptions are inevitable because whatever planning you do, because of weather, because of technical problems and other issues, there could be delays, there could be schedule disruptions. So, how do you manage? Now, disruptions are due to uncertainties and they lead to schedule perturbations. They lead to delays, cancellations and rerouting sometimes. And the main problem is that if you delay a flight, there could be a chain reaction effect on the other flights unless you have budgeted certain amount of slack in your schedule. If you have a chain reaction effect, there could be increase in the operating cost, loss of goodwill because passengers will not like an airline which regularly keeps on encountering delay. The schedule recovery is a very important process. It could be reactive or it could be robust, which is proactive. So, normally a robust proactive disruption management is recommended, but sometimes it may not be possible. Sometimes you may have to do it only in a reactive fashion. There are many causes for delay in operations of airlines. The most common causes are the restrictions because of the ATC, and this is very common. In every flight during the peak hours, the pilot announces that we are expected to reach by so and so time, subject to delays due to traffic congestion and ATC. It is very common. And what can the ATC do? If all flights are arriving at the same time, depending on the constraints of the instruments and the facilities available at the airport, they can only channelize a particular amount of aircraft in a given time. Others have to be made to hold up in the air or sometimes even diverted when the weather becomes bad. So, this is very common. Adverse weather is a huge reason for delays, especially in North America and Northern Europe, and in North India also it happens during winter. There are strikes which can happen suddenly. Then there could be late arrival of an aircraft. Because of that, the connecting passengers are going to have a problem. Sometimes we have to delay the flight to accommodate the connecting passengers. There could be problem because of late arrival of the crew or the catering. Then there are maximum takeoff weight restrictions which can happen if the weather becomes adverse, it becomes too hot, or if the winds are going to be in the tailwind direction. There could be restrictions on how much weight you can carry. You have to offload sometimes. Uncommon delay causes of delay are faulty equipment on board, and if it is an equipment which is required as per the minimum equipment list or the MEL, then you can't fly, you have to repair it. Okay. There could be unruly passengers. This is increasing over the time because people are losing their patience, and because of unruly passengers there have been many delays. Last minute offloading can also happen. There could be bomb scares. These are some of the uncommon reasons. Now, when we plan the schedule, there are many things to be kept in mind. You have to keep in mind time zones. People who are ending the destination should also be at a convenient time. You have to look at the constraint because of the availability of station personnel. The equipment has a turnaround time, and you cannot schedule a flight at the airport, the next flight before the turnaround time. And then, as I said, there will be a chain reaction effect. If one aircraft gets delayed, then there is a chain reaction and that can cause a problem. So, there are many disruptive management schemes. As I mentioned, there are two broad schemes. There is a reactive scheme and a proactive scheme. In the reactive scheme, you basically delay or cancel flights. You reroute the aircraft or the crew members. You use a reserve crew sometimes. This can be expensive, but this is also possible. Reserve crew are members of crew who are ready and available at the large stations where you expect a lot of delays and disruptions. So, you have reserve crew members available to take over, and you can also deadhead the crew, as I mentioned to you. The proactive DMS or the disruption management system is to reduce, to give increased turnaround time in the flight scheduling itself. So, you may actually require 30 minutes for turnaround time, but when you are expecting delay, you give a 40-minute time. Okay. You give a buffer of 10 minutes or more. Then you minimize the impact of propagated delays, okay, because what you can do is, if there is a delay and you want to catch up, the pilot can fly a bit faster to cover the time loss. This has happened several times when I have flown from Mumbai to Delhi or back, when the pilot says that we are delayed, but we will take care by flying a bit faster. They do not announce it, but they end up reaching much faster. And then sometimes you can do aircraft swapping. If you are an airline which has got spare aircraft, which is very expensive actually to keep aircraft on ground, but if you have a large airline, you need to have some spare aircraft which can be swapped if time is permitted. Now, let us quickly look at what kind of equipment assignments are possible in service and out service. The equipment can be on, the equipment here means aircraft, it could be on scheduled service. There could be an extra session, additional aircraft to carry more passengers if the demand increases. There could be some aircraft kept for charter flights. Then, because of overall, some aircraft could be out of service or maintenance checks, or sometimes for flight trainings, although many airlines nowadays provide flight training along with normal conventional flights to the extent possible. And then there could be some reasons for which the aircraft has been out of service. For example, if you want to change the seating layout, the aircraft has to be kept away for some time. And as I mentioned, there are line reserves for extra aircraft for emergency. There are many limitations because of the ground facilities and all that. So, let us have a look. There could be a problem with the gate positions, and therefore, you need to have extra time for delay and arrivals. You must have enough ticket counter space. You must allow transfer of passengers and cargo very quickly. Okay. So, you need to control the number of flights which are departing and arriving at the airport at any time, okay, because delay or early arrival can affect the entire schedule. Sometimes you may not be allowed to arrive very early because it is a just in time arrival. You do not have the crew members or the gates or the terminal space to support arrivals. Then there could be delay in operations. So, finally, let us sum up. What are the key takeaways of today's look at airline scheduling and disruption management? The scheduling reflects many factors: internal, external and competition. It is a function of travel demand and the nature of the network, hub and spoke or point to point. The fleet assignment maximizes profits by minimizing the risk with different fleets because of uncertain travel demand. Aircraft routing ensures efficient operations by synchronizing flights with aircraft and crew with aircraft. This is a very, very difficult balancing exercise. Airline crew is a complex problem, and we will talk about it in a separate session, how airline crewing is obtained. And it is complex because of regulatory requirements, because of crew bargaining agreements. And finally, the schedule recovery tactics can be reactive or proactive. Most busy airlines incorporate certain proactive approaches in schedule disruption management, but sometimes the only option is reactive. Thank you so much for your attention.